Okay, hi everybody. So explain how to compute 2 to the z, where z is a complex number. So 2 to the third is just 2 times 2 times 2. And then we proved that this function sending x to an infinite series, the limit of the partial sums of this power series, in other words, 1 plus x squared over 2 plus x to the third over 3 factorial plus x to the fourth over 4 times 3 times 2, which is 4 factorial. This is really a 3 times 2 in the denominator, plus dot dot dot. We proved that if we called this function f, then it satisfies the property that f of x plus y is equal to f of x times f of y. Okay. But, written a different way, we would have said e to the x plus y equals e to the x, e to the y. And now we're seeing that actually this will also be true for other bases, not just e, but we have to actually define what this means. So anyway, all of this was sort of not part of the problem. So we define the notation 2 to the x. Also, writing z is harder for me, so I'm just going to write x. We define 2 to the x for x in the complex numbers by the formula. X goes to 2 to the x. Okay, well, what is 2 to the x? 2 to the x means e to the x times log of 2. Okay, let's think about this. So this is part of the problem, is to say, what does this even mean? So this means take log of 2, which we now know how to do, and then multiply by the complex number x. Then plug the result into the infinite series, the exponential function. In other words, into this. Okay, that's what we get by plugging in x times log of 2 into that power series. Okay, so we know how to compute. We can compute e to the anything and log to the anything. In other words, we can compute log of 2 and e to the x times log of 2. So we can actually do this now. Okay? And then you can prove a bunch of things. Like, you can prove now, let's choose a different color, that 2 to the x plus y is equal to 2 to the x times 2 to the y for all x, y in the complex numbers. So let's look at the proof. So the left-hand side is by definition equal to, sometimes I do colon equals for a definition. So e to the x plus y times log of 2. But okay, this is just multiplication right here. That's the multiplication of a real number and a complex number. In other words, 2 complex numbers. This complex number times this complex number. I guess this is also a real number, but whatever. That's equal to x log 2 plus y log 2 by the rule for the exponential map, right? We already proved that this is true for the exponential. And so now we're just applying it to the special case. Or no, that's not. This was just distributive law of multiplication. That's all it was. Now we're going to use the property of the exponential. This is e to the x log 2 times e to the y log 2. Here is where we use e to the a plus b equals e to the a times e to the b. Here this is just distribution of a multiplication over addition is maybe what people call it. The multiplication distributes over the plus sign. Okay. I mean, just like, if you have 2 plus 3 and you're multiplying it by 7, you can, pull it through and get 14 plus 21 to get your answer of 35. Or you could first multiply the 2 plus 3 and get 5 times 7, and that will also give you 35. So that's distribution of multiplication over addition. You see that? Okay, but anyway, this is 2 to the x. This is the definition of 2 to the x, and multiply by the definition of 2 to the y. And so that's how we prove this property. Which is the right-hand side. Equals the right side of the equation. Okay. That would be the end of our little proof of this. Okay, so this was sort of an aside. It also wasn't part of the problem, so why am I doing it? Well, anyway, let's do part B. How is any of this relevant for the zeta function? Well, the zeta function, what does it do? Zeta function. It sends a complex number z to zeta of z, which is defined as an infinite series, 1 over n to the z, where n starts at 1. In other words, the zeta function is defined zeta of some input, a complex number, to be 1 over 1 to the z plus 1 over 2 to the z plus 1 over 3 to the z plus 1 over 4 to the z plus ... And so even, so in words, I'll say to evaluate even one of the terms requires that we know how to do 2 to the z right there. It also requires that we know how to do 3 to the z right there. It requires 4 to the z. And now we can do it. 3 to the z is defined to be e to the z log 3. 4 to the z is defined to be e to the z log 4. And 2 to the z is defined to be e to the z log 2. Okay, because now we know log, we know how to compute it, and we know exp, and we know how to compute it. And so we can do any of these things, and we can try to figure out how to win $1 million. The ... part is pretty crucial here. Okay, and also if any of you happen to win this $1 million, just remember who taught you about the Riemann zeta function.